So we discuss about the OSPF functionalities, right? Open shortest path first, right? Open shortest path first. We know this is a link state routing protocol, and which is going to be used. Which protocol it is going to be used as a link state? This SPF algorithm. It is going to be used SPF algorithm, shortest path first, and the multicast address of this is 224.0.0.5, and OSPF is going to be support only the equal cost load balancing, right? And here also we have the unlimited hop count, and we have the areas concept in the OSPF. That's what we discussed previously. Then yesterday's class we discussed about the troubleshooting steps, right? So how we can identify the issues, troubleshooting steps we discussed in the yesterday's class. Now we are going to be understand, right? So as in the OSPF, you have the multi-area concept. We have multi-area concept. So in this multi-area concept, guys, okay. So we are going to discuss about the single area. So this is our single area, right? Single area. So the area ID I'm going to take as a 0, right? So in this area, so I'm going to take, this is my R1 router and R2 router. Sorry, this is my R2. This is my R2 router, and here we have a R3 router. So for R1 LAN, we are going to take 1.0/24 network. Likewise, for R2, we are going to take 2.0/24. And for R3, we are going to take for the LAN network 3.0/24. So whenever we take 3.0/24, right? So we used to assign the gateway address, right? So here in this particular interface, gigabit 0/0/0, we are going to assign 1.1 as a gateway. And for this 2.0 LAN network, we are going to assign the gateway as a 2.1. Likewise for 3.0, so in this particular interface, we are going to be assigned as a 3.1. So that our PCs, whenever they try to ping to the gateway 1.1, so the traffic has to be reached to here, right? So this is what our LAN topology. And here in the WAN side, guys, between router 1 to router 3, we are going to be take the WAN network 172.16.1.0/30. Likewise, from router 1 to router 2, here we are going to take 17.1.0/30, and between router 2 to router 3, we are going to be take 172.18.1.0/30. So here we used to get how many IP addresses we used to get in a /30? How many valid IP addresses we will get?
3, sir.
Valid IP addresses.
2, sir.
2, right? 2 IP address. So I'm going to assign here 1.1, here 1.2. Likewise, in this network also we used to get 2 valid IP addresses. So we will assign 1.1 here and 1.2 here. So here also we used to get 2 valid IP addresses in this 18. So Pallavi, here you used to get 172.18.1.1, and it will go 1.2 and 1.3. So whenever you see 0, this is nothing but network ID, right, Trishita? And the last address used to be become as your broadcast address, broadcast ID or the broadcast address. So we are getting only 2 valid host, 2 valid addresses or 2 valid host IP addresses that we are going to be assigned here as well here to form the neighborship. There is a condition, right? There is a condition to form the neighborship between the router 1 and router 2. If you are taking these 2 routers, both the routers should have a same network, right? Same network. So that's why we are going to take here /30, and 1.1 here we are going to be assigned here 1.2. Likewise here also. Clear? So previously we performed like RIP, routing information protocol, and we performed the EIGRP, enhanced interior gateway routing protocol, as well as we discuss about the functionalities of OSPF. Now today we are going to do the lab for the OSPF, right? So, and one more thing, Pallavi, you had a doubt, right, regarding in yesterday's session. So in EIGRP, to form the neighborship, both the routers should have a same K values, right? Both the routers should have a same K values and same timers. So in our previous lab, we've modified the K values in both the routers. So in one router, we configured as a default K values like K1, K2, K3, K4, and K5. Here in this router we modified the K values, due to which the neighborship was got down and we are getting keep on alerts, right? The K value is mismatched, but we haven't performed the timers things. So in the EIGRP we have the default timer, so both the routers has a default timer, but I just gone through that lab as well once again. In packet tracer, okay, in packet tracers we don't have that command to modify the K values, so we can perform this K values modification in EVENG advanced lab. So to modify the K values, what you need to do, I'll tell you here. So if you want to modify between router 1 to router 3 or router 2 the K values, right? So whichever the interface is going to be connected towards the other router, that interface you need to be modified. For an example like this interface, so here we have a gig 0/0/1, right? Gig 0/0/1. So this interface, once you enter into here, so here you can modify the timers like IP hello-timer interval. Here you can modify the time. Likewise, IP hold-timer interval, and here you can modify. So if you modify one side in one router, on the other router you are using the default one, then the neighborship is going to be down. So this command you need to be performed, but the packet tracer is not supporting for this. I perform in my EVNG lab and it's working fine. So when we are doing the CCNP kind of troubleshooting, then I'll show you. For time being, if you want to understand, you can see here. So this is my one of the router. So interface, let me go here, configure terminal, interface, gig 0/0/1, just hit enter. If you use question mark here, see, IP, you'll get, let me maximize this, yeah. So here you will get that IP, where is that command? Okay, I'll type this IP. Then you will see here hello interval, right? So we can modify the hello interval. You can see here configure IP EIGRP hello interval. So you need to use this command hello interval, then EIGRP, then you can modify the time, the AS number. Based on the AS number, you can do the AS number. Then see here seconds between the hello timer transmission. So here you can modify that time. So if you see here, you don't see the hold on timer command here. The packet tracer is not supporting, only it's supporting for the hello timer only. You will not see the hold on timer or the dead timer things. So for that I told you, so I'll explain you in the EVNG lab. We'll do that in the EVNG lab, right? So that is what the yesterday's doubt, Pallavi, we had. So this is what our lab, guys. Okay, so before we do the lab, so what we need to go through that, so we need to go through with the syntax, right? So let me explain you the syntax first, then we'll perform the lab, then we'll understand how it is going to form the neighborship. And here, so once it form the neighborship, right, you will see the as a full state. So how many states do you have in OSPF? What is the OSPF states? Pallavi and Rishita.
7, sir.
Okay. Okay, down.
Init state.
Init means?
Initialization.
Okay. Then?
Two-way.
Two-way.
Exstart.
Okay, then?
Exchange.
Then?
Load.
Loading.
Unfilled.
Full. So once we configured OSPF here, right, and here as well. So once we've done the OSPF configuration, if you check the show IP OSPF neighbor, you will see as a state as a full. I'll show you that as well. Okay. So do remember this, the states. In interview, it's a damn sure question. So what is the states? How many states do you have in a OSPF? So before they become a neighbors, they are going to be come through with these states. First it will be down, then init, two-way, extract, exchange, loading, and full. I'll show you once we configure the OSPF here. So let's come to the topic. Now we need to understand the OSPF configurational syntax. So if you know about the syntax, then the configuration is bit easy, right? So for that we need to discuss about the configurational syntax. To configure any routing protocol, first we need to go into the global configuration mode, right? So once you are in a global configuration mode, then you need to configure the protocol. So to configure the OSPF protocol, the commands is router OSPF. So earlier we used to have in EAGRP what we have a AS number, right? So but here you will have a process ID, guys. Process ID, right? Then you can mention router ID, router hyphen ID, router hyphen ID. Then here you need to mention, specify the router ID. So ID is a 32-bit of address, right? That you need to be specified here. Then followed by the network. So how many networks do you have in your router? So whichever the networks you are trying to be advertised in OSPF, that many times you need to repeat this command, network space, right? Then a network ID, network space, network ID. This is the network ID. Then you need to use again the wildcard mask. Wildcard mask, it's the inverse of your subnet mask, right? So here you need to use the wildcard mask. Then you need to use the special command here, area, then area ID. That's it. So if you have two networks in your router, for example, consider this one, right? So here how many networks we used to be introduced? So this is our LAN network we are going to be introduced in OSPF. Even this WAN 1 we are also going to be introduced. This WAN 2 also we are going to be introduced. So this command we need to repeat 3 times. But but the thing is what? So here all these interfaces, all these particular interfaces, it's a part of area 0 only. So today we are doing the configuration of single area configuration, OSPF configuration. OSPF is going to be support for single area as well as a multi area concepts. So in OSPF, in IGP, Interior Gateway Routing Protocol, we have only one protocol which is going to be support for the multi-area, single and multi-area, which is nothing but OSPF only, open shortest path first. Instead of this, no other protocols are going to be support for the area-wise concepts. So now once again we'll discuss about this, guys. Okay, so to configure the routing protocol, OSPF, router, OSPF, here we have the process ID. So the process ID is going to be start from like 1 to 65,535. 1 to 65,535. So when you are going to configure the EAGRP, guys, right? EAGRP. So if you are configuring EAGRP in router 1, which is connected towards your router 2, we have a LAN in both the router 1 and router 2, right? So I can configure AS number 100 here. So if I configure AS number 200 here, so will these two routers are going to form a neighborship? Will form or
No,
not?
sir.
No, right? It's not going to
Yes.
form the neighborship because the inter AS number, right? So if you have the inter AS number, then it is not going to form the neighborship. But in OSPF, you can use any process ID. So in router 1, you can use process in between 1 to 65,535. You can use any process ID. However, it is going to form the neighborship. This is what the difference between the AS number and the process ID. Then this router -id command is common for every routing protocol. When you are going to configure an EIGRP, there you have them some extra command like EIGRP router -id. Then you are going to specify the router ID. But here the command is directly router -id. Then you need to specify the router ID. Network space, network ID, this we already know, and the wildcard mask of that. And you need to use the special command which is area ID. So today we are going to do the lab of area 0. So we are going to be consider all the routers in a single area. So that's why I mentioned here single area OSPF configuration. So we are going to take as a area 0. So each and every syntax we are going to mention as a area 0. So if you have any doubts in the configuration syntax, do let me know. Likewise, EIGRP is going to maintain 3 tables, right? 3 tables. So how many tables OSPF is going to be maintained?
3, sir. 3, sir.
So OSPF tables name, can you list down OSPF tables? First table is what?
Neighbors. Neighbor table.
Neighbor table. So will contain the directly connected neighbor information, which means if you are going to consider this your router 1 and router 2 and router 3. So since here in router 1, if you run the command to verify the neighbors, you are going to see your router 2 and router 3 directly connected. So consider if I have a router here, one more router, router 4. So this router can become the neighbor of router 1?
No, sir. No, sir.
No, right? Why?
It is not directly connected.
Exactly. So in IGP protocols, especially do remember this point, in IGP only directly connected neighborship only we can form. But when you are going to configure the EGP, exterior gateway routing protocol, which is nothing but BGP, border gateway routing protocol, there we can form the directly and indirectly connected neighborship as well. That's why BGP is going to be called as a king of the routing protocols. Okay, so whenever you have the ISP connectivity, definitely you will have a BGP only, not the IGP. IGP is going to be used where? I mentioned this point clearly. We are going to be use only IGP protocols only within. I'm giving hint also. Do remember, IGP protocols we are going to be used within the organization or within the autonomous system, right? Within the autonomous system, IGP protocols are going to be configured within the autonomous system. Consider this is your AS100. So here we have a multiple routers which are connected with each other, right? And here we have another AS autonomous system AS500. Here also we have a routers which are connected with each other, right? So within the AS we are going to be run IGP protocols. Interior gateway routing protocols, you can configure here RIP to form the neighborship between these 3 routers, or EIGRP or OSPF. Likewise, here also you are going to be configured within the AS, you are going to be configured the IGP protocols, which means RIP, EIGRP or OSPF. But to communicate between 2 different autonomous systems, what routing protocol we are going to be learn? We are going to be run the BGP, border gateway routing protocol. I mentioned this point. This is also again a gunshot question in the interviews for the freshers. Do remember this. Now, coming to the point, guys. Okay, so OSPF will also maintain 3 tables, right? So what is the first table? First table is neighbor table, and the second table is what? Topology table, right?
Database table.
It's a topology table, right?
Database table.
So in EIGRP we used to call as a topology table, but in OSPF we used to call as a database table, but the work wise both are similar. And we have the last table is what? A routing table. Now I need to understand from you guys what is the command to verify the neighbor table.
Show IP. OSPF neighbor.
And what is the command to verify the database table? That is also same, guys. Show IP OSPF database. That's it. And what is the command to verify the routing table?
Show IP route OSPF.
Show IP
Route OSPF.
Show IP route OSPF. If you want to check specifically OSPF routes, then you need to specify here OSPF. So so neighbor table will contain the information of directly connected neighbor information, and a routing table will contain the information of only the successor route, right? Whichever the route is shortest or the best route, that information is going to be contained in the routing table. But in the database table, so we are going to be view as a top view. So the database table will contain the information of a complete or whole topology information. Correct? Now I need to understand one more thing from you guys. What is passive interface? What is passive interface?
It is used to
Stop the
block
hello messages.
alert inside a particular interface.
Okay, so when we are going to configure, when we config any of the interface as a passive, so what is going to be happen? It is going to be it is
Stop the neighborship.
going to stop hello messages, right? Hello messages. If the hello messages are not exchanging between the routers, then what consequences we are going to be faced? So we are going to face that the neighborship is not going to form, right? It's not going to be formed. So in which scenarios we are going to be passive interface? For what reason we are going to be configure the passive interface? Rishita, where are you? Rishita, tell me the answer. For which scenario we are going to be configure the passive interface?
Downstream, sir.
So in downstream interfaces, generally we used to be configured as a downstream or downside, whichever the interface is going to be connect towards your file, like the switch. So on that interface, downstream interface, we used to config as a passive interface to reduce the wastage of the bandwidth, right? To reduce the wastage of the bandwidth. So if you configure the passive interface of any of the downstream interface, on that interface, the hello messages will not go, right? So this is also clear. Now, Pallavi, where is Pallavi? What is router ID?
A router ID is used to find out the router in the topology, sir.
Okay, router ID is going to be
Use
configured
it to identify
identify
the router.
the routers, right? So so how many ways we can select the router ID? So the router ID election, what is the router ID election? Can you list down that point?
Yeah, so there are three ways to select,
Okay.
sir.
What is the
The
first
first
way?
one is giving the importance to the manual router ID, sir.
Okay, the first preference is going to be give for the
Configure
manually configured router ID. Okay, fine.
uh,
Then the second preference,
loopback address, sir.
which loopback address? I have two loopbacks address here. I configured here loopback 1, and I configured even loopback 2. So to which one
I
it is going
just
to give?
I just read it.
So do specify. It is going to give the highest loopback, right? Highest. Second preference is going to give for the highest loopback address. And what is the third preference?
High IP address. So.
Highest IP address, highest physical IP address. So loopback is physical, right? Is the loopback is physical?
No, sir, virtual, sir.
Loopback is virtual, right? See, ఇంటర్వ్యూ తీసుకునే వాళ్ళు అందరూ ముసలోళ్ళే ఉంటారు, వాళ్ళకి తెలియదు. సో యూ నీడ్ టు బి స్పెసిఫై clearly. Okay, so first preference is going to be give for the manually configured RID or router ID, and the second preference is going to be give for the highest loopback address or the virtual address, physical IP address, right? Highest physical address or whichever the configured on the physical interfaces. So these are the functionalities which we already discussed in EIGRP as well. Everything is same in OSPF as well. And we discuss about the configurational syntax, right? So we discuss about the configurational syntax. So here we are going to be use the area 0 single area. So all these interfaces you can see here. So in area 0 only, right? So even this interface also and this interfaces also. So for today's lab, I'm going to do only the single area concept. But you need to do tomorrow, right? So tomorrow you have to be perform a lab like this. Okay, these two interfaces, and even this 3 and these 2 interfaces. Till here you can consider as a area 0, but for this guys, okay, for this interface you can consider as a area 1, and for this interface you can consider as a area 2, and do perform the lab and let me know how it is going to be work. Okay, do spend some mind. Chalo then. So today's lab we will do the configuration. So we all know the basic configuration, right? So first, if you want to configure anything in the routers, so we have how many? Okay, Pallavi, once again question for you. Okay, how many modes we have in my
5, sir.
router?
5,
Five
sir.
modes. Okay, very good. Can you list down the names?
Setup mode,
Okay, setup mode.
user mode,
Okay, user mode,
privilege mode,
privilege mode.
configuration, global configuration mode,
Okay, fine. Configuration or global configuration mode.
interface mode,
Okay, interface mode.
and line mode, sir.
Then you said 5
mode.
modes, right?
Oh, sorry, sir.
Line mode as well. Okay. See, even if you say wrong, also I'll tell right. Okay. Then when you are going to elaborate that, right, then you will get to know. So we have 6 modes actually. Okay. So when you are going to see the setup mode, this is also I mentioned.
Initial
When you are going to
configuration, sir.
not
If we need
initial
to access
Clear out
router
how
for
to
the
get
first time, sir.
reboot.
right, answer is right, only for the first time. Okay, in a life, only for the first time. So if you got the router in your production or in your organization or in your data center, right? So when you are going to access this router with the help of, once you powered on this router, right? So once you powered on this router, so to configure this router you used to use a console cable, right? With the help of console cable you are going to take the access and you are going to configure, right? For the first time only you are going to see the setup mode, since from the second time you are not going to see setup mode. Only for the first time you are going to see the setup mode, since from after that you are going to see from user mode, privilege mode, config, and line VTY, sorry, interface mode and the line VTY mode. So this mode you will see in your production environment while you are doing the troubleshooting, but for the setup mode are going to be seen only on the first time. So when the first time you receive the device, the branded device or the brandy device, and you are going to be start configuring with the help of console, then only you are going to see. Let me show you this. See here, what is this? Enable. I'm going to see directly enable. So I didn't turn on this router. If I turn on now, if I go click here, see, I'm going to get what, this is what your setup mode, right? This is what your setup mode. Would you like to enter the initial configuration? In setup mode it is going to ask you the questions and answer. So if you go with the yes, if you type here yes, then it is going to ask the questions one by one. So better you'll go give no and hit enter. So if I remove this, if I access once again, then it will directly take me to the user mode. Clear? Even this router also do the same thing. So for the first time it is asking me for the setup mode details. I don't want, so it is going to be take me for user mode. So now, so we covered almost all the basics and the other things. So we will configure the configuration. We'll do the lab for the OSPF and whatever the theoretically we studied, right? So that we are going to be cover now. Clear? So you have an idea, right, about the configuration syntax, or do you want me to write once again? You want me to write the configuration syntax of the OSPF?
Yeah.
Yeah. OSPF configurational syntax, right? So first you will be in a global configuration mode. So here you need to type router OSPF. This is your process ID. Process ID. So here you need to specify the process ID. Then you need to give the router ID command. So the command is directly router-id. So here you need to specify your router ID. That's it. Then the command is network space network ID followed by the wildcard mask Then you need to use your area, then specify the area ID. That's it. So how many networks you are trying to be introduced in your routing protocol, so that much time this net command you need to be repeat. So come exit. This is what the configurational syntax. So in our example we are going to be use area 0, but in router 1, I'm going to use the process ID as a 1. In router 2, I'm going to use as a process ID 2. In router 3, I'm going to use the process ID 3. So when I'm going to configure this as a router 1, so router OSPF process ID is 1, and router hyphen ID. So here I'm going to use 1.1.1.1, then network space network ID. So in my LAN, I have a 1.0 network and followed by the wildcard mask 0.0.0.255. Then area. So all my this interface, which interface? The LAN interface is a part of area 0. So I'm going to be use here area 0. So I have three different networks, right? One is LAN network and another is WAN network, which is going to be connect towards my router 3, and I have another WAN network which is going towards my router 2. So I need to repeat this command 2 more times. So that's what your OSPF configuration syntax.